Brilliant. Guten Morgen. That is my attempt at German this morning, so thank you for having me. I'm actually surprised you all got here because the keynote doesn't start till 10, so you obviously weren't all drinking last night, right? So that's why you're all here, nice and early. You're the dedicated bunch. So my name's Jamie Lee Coleman. I've been here for a couple of years, which not on the planet, but to JCOM, right? So yeah, it's really great to be back. I was actually in Mainz last week at Jack's, so I seem to be in Germany more than I am in England these days. Today, I'm going to talk to you about Black Friday, because Black Friday seems to have become a thing everywhere. And it's our busiest time of the year at Loqate. So I want to talk about how we manage that, preparations we go through, on the technology we use, etc. So a little bit about me. I started off my career as a mainframe developer, which was interesting. So converting PLX tests to Java. I then graduated university, went back to IBM, and was one of the first people to release a containerized image, which was IBM's Open Liberty, or Webs for Liberty at the time. It's now been open source, so do check it out. It's really cool. I then spent a bit of time advocating for OpenJ9, which is IBM's JVM, and I worked at Sonatype for a while. So you'll probably know Sonatype because they run Maven Central for the Java community, which is awesome of them. And now I've gone into a totally new sector in the financial tech industry. Boo. But I'm advocating for a company called Loqate. So the agenda today, I'm going to talk a bit about the history of Black Friday, how we're going about closing down our on-premise data centers, who we are, to give you a bit of context as to why Black Friday is important to my company, the preparations we go through before Black Friday, some of the technology we use to keep everything running smoothly, a couple of issues we've had in the past and how we've resolved them, the future of what our tech stack will look like going into the end of this year and next year. Talk a little bit about premium tier networking, because that has helped us save a lot of money and put a stopgap in place for some things, some useful resources, takeaways, and then some questions at the end. So if you want to ask me questions, please visit this link. I promise you that is a genuine QR code. You're not going to get hacked. But do visit this link and ask me any questions. I'll probably answer them all at the end rather than going through the links there, just so you can type your question while it's fresh in your mind. So the madness that is Black Friday. So Black Friday has, the term, been around quite a while. It actually started in 1869, which when there was a financial crash around the world, gold prices plummeted in the USA, and that is why they started referring to that Friday as Black Friday. If we fast forward a little bit into the 1950s, it was actually referred to as the day after Thanksgiving. And that was because half of the retail workforce didn't show up for work, right? So retailers started calling that Black Friday. And then later on, the Philadelphia police referred to it as the busiest day on the roads in the US. So fast forward to what we refer to Black Friday now. Black Friday is basically the unofficial start of the Christmas period, where companies go from being in the red, so making a loss, to black, making a profit. I luckily never experienced this. I don't like lots of people around me all the time, hence why I'm standing all the way back here compared to you all. But Black Friday has become a thing, and it's become a thing all around the world, okay? Not so much that we're all queuing outside shops to get the latest deal, but the fact we are essentially buying more and more stuff over that weekend. So this was our traffic. So generally our traffic is about double, maybe more than double over the Black Friday weekend period. So overall in 2023, we served 1,550 requests, and that increased a little bit. So every year it goes up more and more and more. It's weird because our European traffic now has outpaced the US traffic for Black Friday. So yeah, the problem is America likes exporting all their lovely traditions, all their stuff to us, McDonald's, KFC, etc. And Black Friday has become one of them, to the point we are now shopping more on Black Friday than the Americans are. So it's not something that's localized to a certain place. I mean, even Asia, we're seeing massive uptake in traffic over there as well. So we're going through a transition period. So the company I work for is over 30 years old. How many people work for a company that's over 15 years old in here? A few of you. Okay, so you're probably going to go through some of the problems we're going through. We predate the cloud, so a lot of our stuff is all on premise. So I like to use this diagram as an example of why the cloud's important, because before the cloud, we had to have the capacity, at least 2 times the capacity that we would normally run throughout the year, right? Yes, we have a few spikes here and there, but generally it's the same level pretty much throughout the whole year. And then we get to certain periods around Black Friday and Christmas where it goes through the roof, right? And we were having to pay for that hardware and run all that hardware to cope with that. So we moved to the cloud, and what does it do? It helps us release some of that hardware to other people, hopefully saving us some money. And then as we reduce our applications down more and more to microservices, to functions as a service, we free up more resources, we have more control, etc. I've used this slide quite a few times, but it basically gets across the message that I try and get across is cloud's computing costs, any computing costs relate to energy, right? Some crazy facts that I think by the end of 2030, 1/5 of the global energy supply will be going to data centers. So every bit of money we can save on the cloud, every bit of resources we can save, we're essentially saving a bit of energy as well, right? So I try and always bring any cost savings, etc., back to the whole energy front. Now, microservices are great, but they add a lot of complexity, as we know. So moving from, no worries. You okay? Okay, cool. No, that's all right. Yes, so they add lots of complexity, as we know. You've probably seen slides like this before. Back in the days when we had our monoliths, we didn't have to worry about a lot of this stuff, my company included. But of course, they all want to jump on the new bandwagon and start building microservices and functions as a service, right? Sorry. So this came around, I think this is around 2008, which was the 12-factor app methodology, right? This basically gave us some really, really good guidelines. Sorry, just muting my phone. Guidelines for how we should develop software on the cloud. So certain things like code base, make sure you've got your code base in somewhere like GitHub, etc., where you've got version control, how you manage your dependencies, where you pull them down from, right? What versions do you use? Configuration. We're very traditionally used to having configuration in our application sphere, whereas nowadays we want to externalize as much as we can. How we handle backing services, how we deal with building, releasing, running our applications, some of the admin processes that are behind this, how we do port binding, concurrency, disposability, dev prod parity is really important. So if you've never used test containers, check that out. It tries to mimic your production environment on your developer laptop, which makes life easier. How we handle logs and admin processes. So if you've never checked this out, go check it out. It's really, really useful. And if you abide by most of this, then you will generally have a good, nice, clean cloud-native application. But of course, as with anything, it got revised. Of course it did. So more things were added. For example, API first. So if you're building cloud-native applications, if you build microservices, functions as a service, you need to have good documented APIs. So one of the things when I joined my current company, I've been here about 8 months now, was our APIs were not documented at all. They didn't follow best practices to the point some of them even used to just return 200 response codes even if it was an error, right? So basically one of the first things I started shouting about is fixing that. As a result, I don't know if you'll be able to see, I basically started using that, is the internet going to die, to create really nice documentation. So if you document your APIs well, not only can you generate things like SDKs, etc., using open source generators like OpenAPI, but you can feed it into nice documentation, which allows your users essentially to get started. Now, as you can see, this isn't live. This is something we're building in the background, but that's just one of the benefits of documenting your APIs, right? And it'll help other teams that are working on microservices be able to work together because they know what, if they send a message to an API, they know exactly what they should receive back and what that API is doing. Telemetry is very important now. We need to know what's happening in our cloud infrastructure and with our microservices. And the one that always baffles me is authentication and authorization, right? Security has never been thought about that much. It's always kind of, we do it because we have to do it, right? If there was no bad people in the world and no hackers, we probably wouldn't even bother with security, but that's unfortunately, we have to. And we're pretty safe in Java because with Maven, you have to own the domain, etc. I think same with PHP, but a lot of the other languages you don't. So anyone can kind of put something into their repositories. Who remembers Log4j, I presume you've all had to deal with? Yeah, okay, cool. Well, still to this date, according to Sonatype, 13% of all Log4j downloads are still that vulnerable version, right? So we need to get better at maintaining and making sure the applications we've got are not vulnerable, and it's very, very easy to do. So this is our application, right? And we've got our app, maybe microservices around, some services that go with it, our artifact repo, and then wherever we put our container images. So mapping all of this onto here, basically, if you abide by the 15 factors or try to abide by them as closely as possible, then you're going to end up with a really robust cloud-native microservice. So that's what we're trying to do. Now, there are some caveats with this stuff. A lot of us like to jump on the new shiny technology. Oh, it starts up in less than a second. Amazing. Let's go for it, right? That's all well and good. And we could probably do with some more of that in Loqate because some of our services do take like 5-10 minutes to stand up. But there are trade-offs with everything, right? If you want something that starts up really quickly, the trade-off might be throughput. So, for example, OpenLiberty with a Spring app and say you're using Tomcat. Yes, Tomcat was starting up a little bit quicker, but the throughput is half, for example. So do you really want to run double the amount of services? Does startup time actually mean that much to you? So don't just jump on the new technology because it's nice and shiny and it starts up really quickly. Have a look at your actual business requirements and see, do we really need it to start up that quickly? So some context of who Loqate are. Any of you heard of us before? No, okay, good. It means I'm in the right place because I'm here to educate you on Loqate. So we've been around quite a while. The big company I work for, GB Group, has acquired lots of different companies over the years. One of them was Loqate. So we basically have the biggest address database in the world. So if you start typing something into your address bar and it comes up with some suggestions, it's pretty much either us or Google most of the time, right? We separate ourselves a bit from Google by having better data because we actually go and buy our data. We go and get it from the post services. We get it from anywhere we can, right? Whereas Google tries to build their own database. But of course, there's problems there because, for example, my house in the UK doesn't have a house number. It's got a name, and it doesn't exist on Google where it does here. And I've kind of tried not to put my address into Google just because I want our data to be better. But I caved in the other day because someone couldn't find my house. So I was like, all right, fine, I'll add you to Google. But yeah, we essentially do stuff like this. So we work with lots of big companies around the world, IBM, Oracle, Microsoft, Nike, I think, is this one? Yeah, so Nike, etc. So if you're using a lot of these different services from these companies, you'll probably be using us. There's stuff like verification to verify if an address is real, and phone validation, email, and bank, blah, blah, blah. But that'll give you some context as to why Black Friday is particularly busy for us because it's everyone shopping online to buy their Christmas stuff, right? Awesome technology. So we start the preparations about 3 months in advance. We do some more work a couple of weeks and then more work a couple of days. So I'll go through these. So 1 to 3 months in advance is when we really start getting prepared for Black Friday. So we generally see about double the traffic, maybe a bit more on Black Friday. We currently have 3 data centers, so 1 in the US, 1 in the UK, and I think 1 in Germany actually. But we have to basically test for capacity. So we do platform testing and load testing on the actual product. We do that for 3 times the capacity because we want to make sure that if one of those data centers falls over, one of our other datas can pick up the work, right? And that is one of the reasons we've had issues in the past. So what I suggest, if you're doing any platform testing and load testing, and for the product load testing, we basically we use Chaos Monkey and we build lots of different kind of sample products, so what we expect our customers to be doing, and then we hammer our services with that. But what I would suggest is if you're doing this, and we do this in production as well, we do all this testing in production because then we know that, well, basically we're double as happy that everything's going to work on the weekend, right? But what I would suggest, if you are doing this kind of testing in production, let your support team know, because if there is any outage, they know how to respond and they know what's going on. Whereas if you don't let your support team know that you're doing this, you're testing in production, and there is an outage, they might not be able to respond to the customer as quick. So 1 to 2 weeks before Black Friday, is when we start scaling everything up, right? So we do a lot of manual scaling, but just because some of our services take a while to come online, and that just gives us a bit of peace of mind that the capacity is always there, right? Yes, it might cost us a little bit more, but as it's our main busy period of the year, we like to manually scale everything up. We scale everything down around mid-December. Now we've put some time-based configuration in, which basically monitors our traffic around that time. And if it goes down to normal levels or around normal levels, then it will automatically scale down, right? But we do manually put that into the configuration that at this date, we want you to start looking at the traffic and then scaling down. Again, I can't stress this enough, is if you're doing any testing in production, please let your support team know and possibly send your customers an email or notification or something just to say, look, we're doing some testing to make sure our services are robust over Black Friday. There might be a bit of slowdown or some outages. You don't have to, but it's nice to just let them know just so they're aware. Now, 1 to 2 days before, we actually take down one of our data centers a couple of days before just to make sure traffic is rerouting to the other data centers and then bring it back up. It doesn't take very long to take down a data center. It takes a bit longer to restart everything back up. But we do that just to make sure all the load goes to a different data center. What I suggest is to disable non-essential jobs. Any server patching, we don't want to do that. Update, basically we disable a lot of our usage services, and I would basically stop any database maintenance at that time. We don't put any updates to our location data over this period. Someone asked me recently, what if I build a new house on that Friday? Yes, you won't be in our database. You probably won't be in anyone's database, to be honest. But yes, we do stop adding extra data in on the Friday, and we resume on the Monday. And again, notify your support team so they can let the customer know. So what's some of the tech that holds up this stuff? Well, we're kind of between here and here pretty much, right? So we're trying to uncouple lots of legacy, large applications and move them into different things. So we've got a combination of virtual machines and Kubernetes. Pretty much anything net new will run on Kubernetes, and some of our older stuff is all running on virtual machines. This is actually quite useful, having both of these things, because cloud providers like to bring up the costs of things. And when you have the ability to move around technologies, move around cloud providers, it means you can negotiate a much better price. Also, it gives us stuff like reliability, failover. The Kubernetes stuff's a lot more scalable, and again, it can help reduce cost, right? Some of the supporting services, so we've got Google PubSub. I'll talk a little bit about that in a minute. BigQuery we use for basically getting usage data, reporting data, things like that. We don't actually use it yet for our address services, and then the built-in Google Cloud Monitoring and Cloud Logging. So yeah, due to a lot of acquisitions, we're kind of in this weird middle space where we're trying to uncouple things. Now, we did actually go down the route of starting to rewrite everything, realized that wasn't a good idea. It wasn't as fast as our monolith by any means. So we then basically went back to the monolith and started breaking it up again, because that way we could do it in small chunks and we could constantly monitor the repercussions of the performance as we broke it up. So we can break off a little bit, okay, the latency's been added a little bit here, we break off a little bit more, and then it helped us decide essentially what route we want to go down, if we want to continue down this route. Because for us, latency is really important. We want, basically, as people are typing, it instantly to go to our servers, fetch the addresses back, and put it in the user's web browser. So we want sub-second response times, and that's what makes latency really important. Now, Google PubSub's quite cool. It's kind of like a mixture of Kafka and RabbitMQ, things like that. So we basically started using PubSub because currently what we were having, we were synchronously talking to our database, and if SQL went down or we had any connection issues there, it ended up blowing up all our web servers. So adding Google PubSub was quite simple to do, and it stopped our servers going down whenever there was a connection issue to the database. It's one thing for the customer not to see a list of addresses. It's another thing that when that doesn't happen, it blows up our servers at the same time, right? So Google PubSub was really useful there. Like I said, it's like a mixture of Kafka and RabbitMQ, ActiveMQ, etc. So it's really, really quite useful. This was an example of a customer in a company I used to work for. They had a unique problem where they were a telephone provider. I think they're quite well known in Germany, but I'm not sure I can list them. But they had this problem where a new iPhone would come out. All of a sudden, they would have a lot of people accessing their website. So moving all that architecture to something reactive and putting these kind of queues in place, basically up their conversion rate from 1.9. The page response time was 7 to 10 seconds. Can you imagine waiting for that? Now, people did because it was an iPhone or whatever, but at the end of the day, that's not good enough. So using to this more reactive architecture saved them a lot of time, a lot of money, and made their customers a lot happier. So if you do get a chance and there is any way you can insert it into your technology stack, it can help in a lot of different ways. So we have a mixture of new and old technologies. So we've got a free tier web application. Listen to this. But our main monolith is called services. Who calls their monolith services? Do you know, it took me probably 2 months of working there to understand what they were talking about. They kept referring to services and services and services. I thought they meant all the services. No, they were referring to one service called services. So this is essentially our big monolith. All the traffic goes into this monolith, and then we send it out to all the different products and all the different services, all the microservices we've got. It's been broken up into to microservices. So we did try and rebuild services from the ground up in microservice architecture, but we noticed the latency was just nowhere near as good. We don't generally have to scale services that much. It's really kind of, as we've broken stuff out of it, we can kind of just leave that monolith as it is after a certain point, because really all it's doing is acting like a gateway for our services. As you can see, the confusion, services. Anyway, services is backed by a web database, which we're slowly moving to MongoDB. But yes, all our address data is in a normal SQL database at the moment, but we're trying to move out of that. Where was I? Oh, yeah, and we also, we had 1,200 services running at one point. So we're trying to bring the number of down, but also introducing more services because we're using microservice architecture. So the fact we managed to cut it down to 400, I think is pretty good. But how does traffic balancing work at the moment? So it's all generally location-based, latency-based. So if you're in the US, it would generally bounce to a US data center. If you're in Germany, it'll go to a German one. If you're in the UK, it'll go to a British one, right? So that's basically how we do it at the moment. We actually still run a service which is 24 years old. Isn't that amazing? That API has not been taken down in 24 years. Why do we have this problem? Well, besides our big customers, we have lots of small to medium-sized e-commerce websites. You know, someone selling towels, someone selling chairs, etc. Now, some of these people set up their e-commerce sites such a long time ago, and they were using like our self-service option, that we have tried to contact them and we can never get a response back. So the way we do it currently is we'll release a new version of the API every time so we don't break any of our previous old customers. But as we can't contact them, 10,000 of our customers, if we turn this service off, a lot of them will just stop working. And they don't have developers, they don't have engineers. These are very small e-commerce sites. So at the end of the day, once it's broken, they'll probably just stop using our service, right? Unless they can hire an engineer to come and fix it. So that is the reason we're still running a service after 24 years. So what are some of the issues we've seen in the past? Well, generally it's always a scaling issue, right? We've seen quite a few over the years. So like I talked a little bit about why we inserted PubSub was because sometimes the synchronous calls would get all mashed up and it'd end up taking down our web servers. And also the SQL database connection wasn't always that reliable. But we've had lots of other issues in the years. And the reason we do a lot of manual scaling is because before we were relying a lot on auto scaling, and as our services take a while to come up, we couldn't rely on this doing it quick enough, which means our customers weren't being able to use our service. So we've done a lot of work to decouple a lot of these different elements as much as possible. We added a caching layer between our web servers and SQL, which helped a lot as well. So the last kind of big problem we had was in 2020. So what happened was the US on-site data center crashed, so it's before the cloud. And then all the traffic got rerouted to our non-cloud European data center. And of course, the firewall shit the bed, so to speak, and went, whoa, what is going on? And this time, it was when Black Friday was way, way more popular in the US than over in Europe. Now, it's more popular here. But the firewall kind of went, no, this is not right. I'm being DDoSed, etc. I'm going to stop all traffic going into our data center, which kind of basically stopped our services working completely. As you can imagine, lots of engineers got calls in the middle of the night because it was on American time that this happened, and had to basically fix the firewall rules and get the data center running again in the US. So moving to the cloud helped us save a lot of this stuff, right? Clouds are a lot more reliable generally. They've generally got a better uptime because they have to adhere to certain standards. And obviously using more advanced firewall configuration fixed this problem. So what tech are we looking to the future for? Where are we going to go? So to improve scaling, we're trying to remove as much manual elements as possible. That doesn't mean we won't technically be manually scaling stuff. It means we'll probably put in the configuration to make it scale automatically. So by that I mean at 2 days or a week before Black Friday, then we'll tell the configuration scale up, right? So we'll put basically a date to do that, okay? So it'll automatically scale up on that date. Trying to move more stuff into microservice architecture means we can do more auto-scaling, but again, because this period is so important to us, we want to do as much manual scaling as possible, and a lot of better monitoring of all the traffic, and times and dates added to configuration, like I said. Geo-distribution for failovers is important as well, so trying to have more data centers in more locations will help. Better capacity spreading across our data centers, because at the moment, a lot of it, we just do it location-based. And trying to use more multi-cloud, right? I've been a big advocate for using open source technology and being cloud agnostic because, as we've seen with certain cloud providers that now have us all running on them, they can start jacking the prices up. And because it's so expensive to move out of their ecosystem, they know they can keep putting the prices up and we will have to pay it, right? Whereas if we put our technology stack into an open source, using open source, it means it's a lot easier to move around different clouds. So MicroProfile is a great example of an open source microservice framework for Java. But this has helped us a lot. Now, we were kind of forced to do this anyway because Nike, for example, wanted us to run on AWS. Now, we run everything on Google Cloud. So we had to do that for them. But as a consequence of that, it means the way we've kind of architected some of our stuff means we can move our stuff onto different clouds quite easily. So if Google in the future start trying to charge us a huge amount of money, we can go, all right, we can literally turn that off and go straight to AWS or vice versa, because we've built our technology in a way that it's cloud agnostic. So that is really important as well. So the 2025 plan. We want to bring on a new US data center. So we've got one in the center of the United States at the moment. Like I said, one in Germany and one in the UK. So what we've started to expand into Asia. Now, the cost of setting up a new data center or bringing our new clouds region online is quite expensive. So what we are doing is we're using Google's premium networking tier. And I'll explain a little bit about that in Amazing. It's really, really cool. Later on in the year, we will, when the business case is there, when we can basically convince our bosses, my CTO and everyone, that the capacity is now in the US data center too large to warrant us doing this, then eventually we'll bring an Asia data center online. But essentially what we're using is Google's backbone, which is really, really cool. So as you probably all know, this is kind of how the internet traffic works. Generally, you've got your Google Cloud platform, your Google Cloud, your cloud, whatever. It comes out near that data center. That's where the traffic comes out, hops around the internet, and then finally gets to the end user, right? Google has been laying lots of network cables for a very, very long time. And if this was a game, this would be my favorite game. I'm a bit of a nerd, but yeah, I love tidying up cables and stuff like that. That's essentially what Google's been doing around the world. They've been laying cable after cable after cable under the oceans, through land, etc., to build their own massive network infrastructure. So if you're using, for example, Google's backbone, if you're using their premium network service, this is how it works. Instead of coming out of where your data center is, they feed the traffic along Google cable so it doesn't have to bounce around as much, and it exits near its destination, right? So this has been a really good stopgap for us, because it means why we don't have the business case to warrant bringing a data center online in Asia. It means we can still serve those customers with reasonable latency. It means using this technology and Google's internet cables, we can essentially get that traffic to them, to and from them quite quickly. And this is an example. This is what Google have been laying all over the world. They have data cables absolutely everywhere. If you compare Google to some of the big technology companies, Facebook really is the only company that's laid nearly as many cables. Amazon is trying to play catch up, Microsoft is trying to play catch up, but Google has been doing this for a very long time, pre the cloud, I would say. So but you can take advantage, if you're on Google Cloud, of this premium network service. This is going to be really useful in the future for IoT devices, because we're not always going to be able to set up data centers next to these devices or their locations. So being able to take advantage of this kind of network capabilities to bypass jumping around lots of routers around the world can help improve the latency on those devices, which is pretty cool. So we've also, over the last 3 months, been trying to reduce our cloud costs. So for example, we'll have basically, we have to have a minimum spend on Google Cloud. We were over that by about 60,000 euros per month. So we did a lot of work to basically reduce our cloud costs. That has resulted in lots of other benefits. So automation is one of the things, and that's helped us bring down cloud costs. Improving the service startup time brought down our cloud costs quite a lot. Moving from Windows to Linux, right? Windows is quite a heavy OS, as we all know. Don't get me wrong, it's great for running computer games, but not so much for running our cloud services. So moving as much from Windows to Linux as possible. A context engine, that helped save quite a lot of money. Having backwards compatible services. So there's lots of different things to think about here when you're trying to make sure your services are reliable, they're scalable, they're robust, etc., things like that. Some of the takeaways and things I want you to think about. Capacity testing must be done way ahead of time. Don't do it a few days before, because if you run into any issues, then that could cause problems. I would say if you have a specifically busy period, yes, we have lots of modern auto-scaling technologies on the clouds nowadays. But if you do have services that are a bit larger and take a bit longer to come up, and you care about latency, then I would say manually scaling things is important. What I'd like to also say is make sure you keep your users in the loop if you're testing things in production like we do. Again, we do that just to make sure it's going to be exactly the same environment, the whole thing, dev, prod, parity. Hire a good platform engineer if you don't have one. So we hired a really good platform engineer just over a year ago. These people, they live and breathe your technology platforms, right? Nowadays, I see a lot of engineers, developers, I should say, are being expected to be able to know how to be platform engineers as well. And I don't think that's right. Yes, we can learn a lot about it. I know a lot about it. I wouldn't consider myself an expert. And when this guy came in, he basically rewrote the book. A lot of people were really scared at the beginning because he was making massive changes, but they've resulted in not only our services being more reliable, but a hell of a lot of cost savings on the cloud. We probably pay his salary now in the savings we made over 3 months every 2 months. So if there's not a business case there for you guys to hire a good platform engineer, then I don't know what is. Keep all stakeholders in the loop, I would say. So make sure support know what's going on, make sure your dev team knows what's going on, your testing team, etc. Right? Again, automation is key for a lot of this stuff, but should not be solely relied on, especially if you've got really important periods. My advice there is generally, yes, it might cost a little bit more to scale up a bit earlier, but keeping our customers is a lot more important than minor cost increases. So that is my advice if you have a specific busy period. There's some links here to some of the stuff I've talked about in the presentation, so feel free to go check those out. Do get in touch with me. I don't use Twitter as much anymore, but I am still lurking around on there. But yeah, you can contact me on LinkedIn if you've got any questions about anything I've talked about today. We have just created a community. So if you're in the retail space, e-commerce, in the financial tech industry, if you've got any questions about some of the stuff we do, then feel free to join us on here. So do we have any questions? Again, you can go on to use this link. Any questions in the room first? No. Okay, making my life easy. Let's have a look on here. All right, cool. So when you are manually scaling up services, how do you know what to scale up, or is it everything? It's generally the backing. It's generally not services itself. So like I mentioned, we have a big monolith called services. We don't really have to scale that much up much. We do a little bit. Probably 2 or 3 times, but generally it's all the backing services that connects to. A lot of that comes as a result of the load testing on the application itself. So we basically look at those tests, we figure out which services are struggling, so looking at your telemetry data and your metrics, looking at which services are reaching kind of the peak threshold and the throughput starting to drop, and then we scale those ones individually. So yeah, generally what we do is we try and look at the testing of the platform, the testing of the application, check which services are reaching their throughput and throughput starting to drop, and then we slowly scale each one of those. Hope that answers your question. Are microservices called microservices? What does that mean? I don't know. Yes, I guess they are. Go on. If someone in here can elaborate. Anyone? No? Oh, right. Yeah. Yeah, that makes sense. Yeah. So yeah, there's your answer. When you've done that one, how do you manage API backwards compatibility? Yeah, so I mentioned this. So how we manage it for our customers is we generally release a new API for our new products. So I think we're on version 5 now. We don't release them very often. It's when a product is going to dramatically change on the customer side of things. That is how we basically do that, because again, we have like 10,000 customers that don't have developers, that don't have engineering knowledge. So we don't want to break those old customers. So what we do is we basically release a new version of the API. So hopefully that answered your question there. Has scaling up cloud resources Black Friday ever seen a problem, since a lot of other companies scale up at the same time? That is a good question. I don't actually know, but that'd be really interesting to find out. So if anyone works for a cloud provider, if you could let me know if you've ever seen anything like when everyone scales up, if they've had any issues. Then you're not going to tell me that, are you, even if you do work for a cloud provider? I'll try and find out. That is an interesting question. I imagine it must be quite a big, heavy load on the cloud providers, because a lot of e-commerce businesses are doing this, right? So yeah, good question. I don't know the answer to, but I'll try and find the answer to that. Why do testing on production? Why do you replicate conditions on stage, infrastructure as code? We do that because even with the best technologies out there, like test containers, etc., you're never, ever going to have exactly the same environment on your laptop or as on a testing machine. Okay, yes, you could on the cloud, but you're never going to have exactly the same environment, right? There's always slight differences, maybe a slight configuration change, etc. So we do it in production just to make sure. Now, we do it slowly, so we ramp it up, and if we see at any point any problems that with our latency, then we'll pause at that point, scale it back down and figure out what the problem was and try again. So we do it in a very careful way to try and not impact anyone. We don't just scale up massively. We just do it bit by bit. But again, we do it in production just to make sure we are 100% sure that the environment is exactly the same as what's going to happen on Black Friday. Yes, there's a question. Yep. So there's not one bit of difference in your production and your testing environment? Yeah. Yeah, so I mean, I agree in some case. And again, I've been a big advocate for trying to have dev prod parity wherever, especially in your testing environment. That's just the approach this company decided to do, right? It's just basically what we did. A lot of our stuff, so we haven't got everything as configuration as code either. So moving to more Terraform could probably help with that. But whether or not they would decide to not test in production, I don't know. I think one of the reasons we've kept doing it is we've done it in a certain way there it's never impacted our customers. So by doing that, we're happy to keep testing in production because it just gives us that peace of mind, right? But because we test slowly and we increase slowly, it's never had a problem. So that's why we decided to go with that route. But yes, you can try and replicate it as close as possible, things like Terraform. What kind of data set do you use for the load testing? Prod, Do you also take location EU into consideration while testing? Yes, so we basically take our structured location, our unstructured location data, so not the structured one, and we throw that into, we basically have some sample applications which hit our services really hard. And we basically, so we've got some different tools. So we've got an AI tool which takes unstructured data and structures it into our database. But a lot of the time, people, when they're typing into some of these things, it's kind of in a half unstructured way, let's say. So we take our unstructured data, we feed it into our sample applications, and they basically constantly keep hitting our services. We use unstructured data from the US, the EU, Asia, Africa, everywhere, basically. We try it with different things. So, I mean, our best data we have is for the US and the EU. We've partnered with Grab to get better data in Asia, which is interesting because theirs is all completely unstructured. But yeah, we basically take the data from our unstructured database, and then we basically feed that into our sample applications, which are our servers. So. How do you handle data replication between data centers? So most of our data is in one date. It is like coming from, yes, it's got disaster recovery, etc. So if it goes down, but most of our data comes from one source. So we essentially take our data from lots of places, we put it into one database, and we eventually feed that into all our. So we don't have to do that much replication. The only place where we have different data set is I think China doesn't allow location address data to go cross borders. They count that as personal information, whereas most of the world doesn't, right? I mean, I can go stand in the street and get any address, right? As long as there's no name attached to it, it shouldn't be considered personal data. But China does, so we have to do some weird stuff in China because obviously some of the Chinese companies that use us, they are spreading into Europe, etc. They want to serve the customers here, so they need our address data. I think we're allowed to put address data into China. We're just not allowed to take it out. So there is some replication that goes on there. I'm not sure exactly how they handle the Chinese replication, but generally most of our data is in one place and we just feed it up like that. So we don't worry too much about replication, etc., because most of the world considers address data as not personal. How did decreasing startup time bring down cloud costs? Well, so imagine this. So while your application starts taking a while to start up or do anything, that is completely wasted time, right? You're essentially paying for cloud resources while your application is getting ready to start. So if that's 10 minutes, that's 10 minutes of cloud resources I've just paid for and I've not served my customers. And if I've got loads of those services, that adds up quite a lot over the year. So basically not only getting the application to start up quickly, but to ramp up quickly. So be able to receive throughput as quick as possible. That is what saved us lots of money because it's reduced that 10-minute time for each of our services to start up. down to a couple of minutes. So we've basically got 8 minutes worth of savings there. And as we're doing that on a regular basis, standing things up and scaling them down, it saves us quite a lot of money. So that's how startup time helps us save a bit of money. Do you use cloud run on GCP? Yes. So we use everything pretty much on GCP, except for some of our customers that request on AWS. Is it really a good idea to rely on something like AWS Lambda for better scalability? It is, but our applications, again, are quite old and quite big and quite chunky. We could start rewriting we could start our new applications basically to use something like AWS Lambda, but then we get into the whole thing where we're stuck into an ecosystem again, and AWS are notorious for increasing cloud cost prices, so we're trying not to use any specific technology that is focused on a specific cloud. We're trying to use cloud agnostic technologies. That is probably one of the reasons we've tried to avoid using AWS Lambda, and to be honest, most of our stuff's on Google Cloud anyway. Decrease latency, error in PowerPoint, thank you. So I think that's everything. I hope you have enjoyed my session, and you're all here, which is amazing because it's actually before the keynote, which is surprising. So I'm just going to take a picture because it's really sunny and my boss is going to think that I'm on vacation. So hands up, everyone. You all love JCon, amazing. Thank you all for having me. It's been an absolute pleasure, and enjoy the conference.